Hi everyone, this is the last video of this week and I'm gonna talk about a mix of topics. First, I want to start by showing you a few, non-standard difference curves. Learning those is useful for two reasons. The first, you do run into these kind of utility function as well as indifference curves from time to time. And secondly, seeing these non-normal cases will help you to understand the normal cases a lot better. So let's begin. The first case I show you here is the perfect substitute. And one example of perfect substitute would be, for example, the good 2 is Coke and good 1 is Pepsi. Let's assume that the consumer does not have any preference over taste or packaging or anything like that. Basically, Coke and Pepsi means the same thing to the consumer. And in that case, the indifference curve is not a convex curve, but rather is a 45-degree line. Basically, the consumer is as better off here. For example, 10 Coke plus 1 Pepsi, and it as if NS is just equally better here, whereas 1 Pepsi and 10 Coke. Oh, sorry. So this is 1 Coke, 10 Pepsi. Basically, as long as the consumer have, for example, 11 tins of these soft drinks, the consumer is happy. There's no marginal utility change by moving from here to here. Therefore, the indifference curve is a straight line. But however, the rule that the further away you move from the original point, the higher the utility, that rule still stands. And if you do have this kind of perfect substitute, how would you maximize your consumption? First, let's take a look at the budget line. This budget line shown here is telling us that the price for a Coke is actually higher than the price of Pepsi because this length here, the intercept with the x2 axis, is shorter than the intercept of the budget line with the x1 axis. That's just basically saying that the price of good 1 is cheaper. If price of good 1 is cheaper and consumer does not prefer one product over the other, then the rational maximizing consumption point is here. Basically spending all the time you have on Pepsi, whose price is lower. So you don't necessarily have to understand this in a mathematical way, but at least you should understand in two ways. First, the intuition. The intuition is that if I don't care about whether it's Coke or Pepsi, and then Pepsi is cheaper, then the maximizing point is where I use all my money to buy Pepsi. And graphically, the intuition is if you want to move this indifference curve as outward as possible, and this indifference curve is the outmost you can get, and it intersects with the budget set at this black dot. So that's perfect substitute. And then let's take a look at perfect complement. So one example of a perfect complement would be left shoe and right shoe. Basically, you can't really, like, one left shoe means nothing to you, one right shoe means nothing to you. It's only one left shoe is paired with the other right shoe, then it's a pair of shoe and then give you some level of utility. And why does the perfect complement have this kinky shaped preference curve? Is exactly because of that. It basically says that, let's say this point is one left shoe and one right shoe. Then this point is two left shoe, one right shoe. This indifference curve is saying that the utility you derived by having two left shoe and one right shoe is exactly the same as one left shoe and one right shoe. Because that one actual unit of left shoe just doesn't give you any actual utility. It does not pair with any other right shoes. And the only way to increase profitability is to increase the number of pairs you have. For example, this is two left shoe and two right shoe. It gives you a higher utility than one left shoe and one right shoe. Okay, but for example, this is two left, two right, but if you are here, which is two left, three right, it gives you the same level of utility as two left, two right, because it's the pair that matters, not the individual number of shoes. Then that's why the utility function takes this form. This form says that the utility level of consuming x1 and x2 is dependent on the smaller of the two. So for example, if I have one left shoe, two right shoes, then your utility level is a small number, is 1. If you have 3 left shoes, 2 right shoes, then your utility is 2. Because 3 left shoes and 2 right shoes give you 2 pairs, and only the pair matters. And then here, when consumer wants to maximize the utility by this budget constraint, then you see that the consumer wants to move as outward as possible, and the outwardmost indifference curve that's within the budget set is this middle blue line. And here, because it's kinky, there really is no tangent line at this point. So the marginal rate of substitution is equal to negative P1 over P2 does not apply here, because this curve is kink and it does not have a slope. The third case is not an abnormal case. It's actually the normalest. The most normal case we see is the Cobb-Douglas. I put it here because I want to show you, like, I want you to match the indifference curve shape we see all the time to the utility function. And remember, we actually introduced 2 forms of Cobb-Douglas, and they are essentially the same thing, but the first form will give you an easier time to compute MRS. And we have seen all these already. So this is a perfectly well-behaving indifference curve. And at this point, it's the tangent is the highest that indifference curve can get within the constraint of the budget line. And at this point, MRS is equal to negative P1 over P2. That's the first topic. The second topic is I want you to revisit consumer surplus as well as producer surplus. By actually giving this lecture to your colleagues on site in person, I realized that you guys may not have as many problems as I thought you had with the consumer surplus. So I'm not gonna spend a lot of time here, but I do want to briefly explain this concept again to you. So this surplus concept really comes from the fact that your willingness to pay as a consumer may not be exactly the same as the prevailed price in the marketplace. For example, if the prevailed price in the marketplace is R3, then the highest willingness to pay is R1. Then R1 minus R3 is the surplus for the person who have the willingness to pay at R1. And then the difference between R2 and R3 is the surplus to a person who have a willingness to pay of R2 instead of the prevailing market price R3. So everything under the demand curve but above the prevailing market price, that area is the consumer surplus. So these are the discrete cases, and then we kind of take the discrete case to the extreme, then we see this continuous case. Then in the continuous case, the consumer surplus is the area between this blue line and this prevailing market price, this horizontal line. And this is a graph showing you if the prevailing market price move from P prime to P double prime, what happens to consumer surplus? So when the prevailing price is P prime, the area between the P prime horizontal line and the blue demand curve above it, the whole region is consumer surplus. But once the prevailing price go from P prime to P double prime, then the consumer surplus is only this area. Therefore, there's a reduction in consumer service that's equal to the area R plus T. And you see that why we want to separate R and T. So the area R is the consumer surplus that's lost to the consumer here in this region who have the high willingness to pay. The T area here is really about the consumer who can't consume anymore. So these consumers here with high willingness to pay, they're just getting less consumer surplus. For the consumers here, however, they kind of lose the chance to consume anymore because their willingness to pay is below the second prevailing price. And that's why we separate these two areas. So that the loss of consumer surplus come from two groups of people. And the same logic applies to producer surplus. Producers have a surplus because the market prevailing price is higher than the cost. So the cost is given by the corresponding price of a point on supply curve. So these are the cost, the blank area. And the whole rectangular area is the total economic, is the total revenue. And then the blue area is the producer surplus, or you can also think of it as the profitability. Okay, so when price goes from P prime to P double prime, contrary to the consumer's case, the producer surplus actually increased. So before it was this small blank triangular area, now it's this bigger triangular area. The increase in producer surplus also has two parts. The first part is the increase in surplus for the producers who are already selling under the lower prevailing price. And the T area is the area that because the price increased, some of the new suppliers can come to the marketplace and supply their goods. And that's the producer surplus accrued to those new suppliers. So the change in supply surplus has two parts, and that's what I mean by that. All right, so that's a brief review of the consumer and producer surplus. They're gonna become important once we get to the point where we discuss, for example, taxation, and we also discuss the welfare implications of certain policies, and that's where we're gonna use this concept. But for now, this is just a brush up to keep this concept fresh for you. The last concept I want to revisit is the elasticity of demand. Okay, so what is elasticity of demand? The elasticity of demand studies how demand quantity, how sensitive it is to the price change. However, it's defined in a unique way. So first, let's revisit the definition of the slope of the demand function. The slope of the demand function measures how quantity changes with price change. Elasticity is defined differently, but elasticity is like a more complex build up on the slope of demand function. So elasticity measures in a percentage sense how quantity changes with price. So basically, we divide the changing quantity by the absolute level of quantity. We also divide the changing price in absolute value of price. Therefore, elasticity starts like if price changed by a certain percentage, how will quantity change in the percentage terms, following the change in the price. Okay, so that's just the only difference is we measure these changes by percentages, but the fundamental thing we're thinking here is still how demand changes with price. Okay, let's look at example of the linear demand function. So this is a linear demand function. A and B are constant, Q and P are quantity and price, and they're variable. And this elasticity is given by, so the derivative of Q with respect to P, which is the slope of the demand function, which is also the delta Q over delta P here, is given by negative B, and times, like we defined here, P over Q. And if we replace Q by A minus BP, this is the second form we're showing here. And I wanted you to take a look at the graph here. It is important to know that along this linear demand curve, the slope is constant, but the elasticity is not. When we are close to this point where Q is approaching zero, so when Q is approaching zero, look at the form that elasticity takes. When the denominator approaches zero, the whole value, the absolute value of the elasticity approaches infinity. And that's why this is infinity here. And if we look at this point, that's when the price is approaching zero. When the price is approaching zero, this mathematical expression approaches zero because the price is the numerator here. And that's why the elasticity of demand is very, very low when the quantity is high but price is low. But it's very high when price is high but quantity is low. Okay, so these are a brief revisit of a few of the topics that's gonna repeatedly come up in the next semester. I'm gonna be your tutor for the micro in the coming semester, and I will also be your teaching assistant for the econometrics class. So we'll be talking a lot next term, and I look forward to it.